I can hear you. Can you hear me?
Yes, we can.
Okay.
All right.
All right, thank you.
Thank you.
That wasn't bad. Okay, y'all ready? Maybe. And your screen's froze. Okay, since I can't see y'all because you're froze, can somebody tell me whether or not if y'all are ready?
Yeah, we're good.
Okay, can you see my Word document, the chapter 15 intravenous solutions?
Yeah,
Okay.
I can see it on your screen, but I don't see it on like on Canvas.
Okay, on Canvas, it's going to be, scroll all the way down to, let's see, week 11.
There's only week 10, there's no week 11.
You don't have week 11? Oh, hang on. Refresh your page. Now you should have week 11.
I just refreshed it, there's no week 11.
Okay, do it again because I just clicked the button. I mean, like 2 seconds ago.
Oh, I see it. Thank you.
Okay, no problem. Thank you for letting me know you couldn't see it. I'm gonna shut my door. All right, so we're looking at IV solutions today. I'm gonna get my screen, my touchpad to work. All right, so the main thing on this with the IVs that we're looking at for right now is that you know the definitions. That's one of the main things. We're not going to do anything with them exactly, except, well, we'll do stuff with IV solutions, but I'll just shut up and do this. All right, so know that D is dextrose. My pen's not going to work. There it is. So D is dextrose. W stands for water. S stands for saline. NS is normal saline, which is 0.9% sodium chloride. So that's 0.9% sodium chloride. And normal saline is the common term for, or sodium chloride, I should say, is the common term for normal saline because it has the same concentration of sodium chloride normally present in the blood. And so you'll see them use normal saline a lot, especially to clean wounds. And then the NC or NaCl is sodium chloride. RL and LR, once the RL is Ringer's lactate, the LR is lactated Ringer's. They're the same thing. It's a mixture of sodium chloride or sodium lactate, potassium, and calcium chloride in water. I don't know the difference between RL and LR. One is, well, they are what they are, but unless it's just the different companies that make them. So when you're looking at an IV bag, you generally have 1,000 liters, which is 1 liter. The pen's not cooperating. You'll have a 500 milliliter bag, I don't know if you have a 750 or not, but I know you have a 500, a 250. There's a 100 and a 50, and there may be, I think, a 25 milliliter bag. And there may be smaller ones, I'm not sure, but those are the ones that I know of. But in the bag, or on the bag, where this one says 5% dextrose, that 5% is the same thing as saying 5/100. To take any number out of a percent, you always put it over 100. So this is 5 grams out of 100 milliliters. It also says it down here in this little box. Okay, so it generally says it on there. And that one doesn't ask the question. So I'm not going to ask you on a test how many grams of dextrose or how many grams of sodium chloride there is in a bag of IV fluid, but I want you to be familiar with it. So on number 2, we have D10W. So this 10 means it's 10% dextrose. Okay. So it says calculate the amount of dextrose in 250 milliliters. So what I'm going to do, since it's 10%, it's 10 grams over 100 milliliters. Gram looks pathetic. And then we're going to multiply it by the 250 milliliter bag. Okay. So cancel out my milliliters. Cancel a 0 here and a 0 here. I can also take this 0 and cancel this 0. So I have 25 grams in 100 milliliters. No, that's not right. 250 milliliters. Why does my pen always want to do this to me? So there's 25 grams and 250 milliliters of 10% dextrose. Okay. Y'all look like you have frozen again. All right. So what we're mainly concentrating on in chapter 15 is we're calculating flow rates. Okay. And this one is for an infusion pump. And y'all have been, if you've been to visit people in the hospital or been in the hospital, most of the IVs are done by infusion pumps. Okay. And we're always in milliliters per hour. That's the rate. And I know you can go in and you can program these infusion pumps, and you can put 250 milliliters as your volume, 2 hours as your time, and it will give you the correct rate. And that's all fine and dandy, but what if the buttons stick and you miss hitting the right button? How would you know it? If you hit, instead of hitting 250, you may hit 280 because you hit the wrong button. Or you could have hit 220 and hit the wrong button. Or maybe you hit 251 and it all throw you out the wrong rate. So you got to know how to calculate this to double check the machines. To calculate the flow rate, you need your volume in milliliters over your time. And this is going to be, it's milliliters per 1 hour. So if I've got a volume of 250 milliliters and it's over 2 hours, I'm going to reduce this. 250 divided by 2, it gives me 125 milliliters per hour. So if you put the 250 in the pump and the 2 hours in the pump, and you don't get 125 milliliters per hour, then something's wrong with the pump. And the pumps do malfunction. I got one in my office that the nursing program gave me. because it malfunctioned. It didn't work anymore. So sometimes I call it volume. Sometimes I'll just say it's the amount of milliliters. So my amount in milliliters over my time. But it's always my milliliters over my time. And then sometimes I will have to convert it because it won't always be in hours. If it's not in hours, then I may have to convert it. Say it's in minutes. I'll have to convert it from minutes to hours. So I'm going to put convert. Okay. So let's look down here at number 4. And just like with any order, sometimes you have more information in the order than you need to calculate what you're going to calculate. Since I'm calculating the flow rate on this one, for my order, it's ampicillin 500 milligrams and 50 milliliters in 30 minutes, I should say, over 30 minutes. But I don't need the 500 milligrams of ampicillin. That should already be in our bag, okay? So all I need is my 50 milliliters over 30 minutes. So it's my total number of milliliters, or my amount, so my 50 milliliters over my 30 minutes. And then since it's in minutes, I'm going to convert 60 minutes to 1 hour. So my minutes are going to cancel. And then I know I can cancel zeros, but 60 minutes, 30 minutes is half of 60. So 30 goes into 30 one time, 30 goes into 60 2 times. So I've got 50 times 2, which is going to give me 100 milliliters per hour. So any questions? Y'all have to speak up because you're frozen. You freeze every 2 seconds, it seems like.
Can we calculate 15 times 0.5 and get the same answer, right?
Yes. Okay, let's look at number 5. And I want you to do this, but I'm going to get it started for you a little bit. Your 2.5 liters, that's still my total amount. I'm going to put it over the 20 hours. But my flow rate is always in milliliters per hour, okay? So I've got to convert my liters to hours, or liters to milliliters, sorry. I have 1,000 milliliters per 1 liter. Now, since it's already in hours, do I have to have a time conversion, or is that it?
That's it.
That's it. Okay. So my liters cancel, leaves me in milliliters per hour. So y'all tell me what my rate is.
Milliliters an hour?
125 milliliters per hour. So flow rate is going to be the easiest thing we do all day. It's the easiest thing we do all of chapter 15. So flow rate, and even the flow rate that we're fixing to do with the gravity flow. So it's calculating flow rate for manually regulated IVs, and these are the gravity flow. Some medications have to be given by gravity flow. Okay, and it's recorded in GTT, which is drops per minute. Okay, so the drop factor, and our drop factor, there's a difference. Our drop factor is drops per milliliter, but our flow rate is drops per minute. Okay, so we're going to use the drops per milliliter to find our answer, but we're going to record it as drops per minute. And the drop factor depends on the IV tubing that you use. Okay, you're going to have your IV bag at the top, and y'all have seen these. And then you've got tubing that connects the IV bag to that needle that's in your arm or in your hand. And depending on how thick or how big of a diameter that tubing has, it depends on what your drop factor is. Okay, some of it's bigger than others. The bigger the tubing, or the wider the bigger circumference, not circumference, what am I looking for? Diameter of the tubing, the larger the drops. So we have our micro drops, which is 10 drops per milliliter. You know, 10 drops is not much for 1 milliliter, so they've got to be pretty good sized drops. We got 15 drops per milliliter. My pen doesn't want to write there. And then we got 20 drops per milliliter. So it doesn't take as many drops for these to fill up a milliliter vial, or that little thing at the top. And then we have our micro drop. Okay, these are very small drops. It takes 60 drops per milliliter. It's also known as a primary IV set, so it's known as a micro drop or micro drip, a primary IV set, and it's also known as having a drop. This also is a drop factor of 60 drops per milliliter. So these are known as 3 different things. And for these problems, you will always be told what your drop factor is, except I got one that I forgot to put it on there. In real life, well, in your order should have your drop factor in there. But you will be sent a package of tubing when you've got IVs, and it'll have on that package, it'll have your drop factor on it. You know, you'll have tubing, and it'll say with it, you know, drop factor 10 drops per milliliters, or it'll say a primary IV set, or it'll, you know, 60 drops per milliliter. So to use these, it says in this first on number 6, I've got 125 milliliters per hour. That's my rate, but that's also my volume. 125 milliliters is my volume. The hour is my time. The infusion set is calibrated for a drop factor of 10 drops per milliliter. And it says calculate the flow rate in drops per minute. A lot of these I will just say to calculate the flow rate. If you're given a drop factor, you're automatically calculating it in drops per minute. So to calculate my flow rate, and I'm wanting it in drops per minute, sometimes I warn you, my GTT, this one looks like a 5. Sometimes my TTs will look like an H. My handwriting is bad. So total volume, total amount, 125 milliliters over my time, which is 1 hour, times my drop factor, which is 10 drops per milliliter. Since I'm in hours, I've got to do the time conversion. 1 hour, 60 minutes. Okay, so my milliliters cancel, my hours cancel, and 10 on top, 60 on bottom. I can cancel just a 0. Our 10 goes into 60 6 times, either way. So I have 125 divided by 6, and it's drops per minute. Now 125 divided by 6. Find my calculator again. Gives me 20.83. All right, with the drop, if you'll think about it, a drop, think about a drop of water or a raindrop. Can you calculate can you count a partial drop? Have you ever seen a partial drop? You've got smaller drops and larger drops, but I've never seen a half of a drop. I've never seen 8/10 of a drop. Okay, the point I'm trying to make is when you're doing drops, they're whole numbers. So I'm going to round this, and depending on where you work, they'll either want it left as the whole number you got, so 20 drops per minute, or they want it rounded to the nearest drop. In this case would be 21 drops per minute. Okay, I really don't care because one drop's not going to make a big difference in your medications. So if you round it and give me just the whole, then it's 20 drops per minute. If you round it to the nearest whole, then this one would be 21 drops per minute. So you could do it either way. Okay. So do we have any questions? So let's look at number 7. I have an order again for ampicillin, 500 milligrams in 100 milliliters of normal saline to infuse over 45 minutes. I want the flow rate in drops per minute. So what are we missing here? Do you know what I'm missing? I'm missing the drop factor. Okay. So if you're missing something like the drop factor, what are you supposed to do? Do we go ask another nurse? Do we call the pharmacy? Do we call the doctor? If you're missing the drop factor is part of the order, okay? So if you're missing part of the order, you would call the doctor. And so you're going to call the doctor for clarification. And he said that the drop factor, oops, I don't have to write that again. So our drop factor is 20 drops per milliliter. So he gave us a verbal order, and we'll talk about verbal orders later on. Or maybe we've already talked about verbal orders. All right, so he gives us, now we can calculate our flow rate. Do I need the 500 milligrams of ampicillin?
No.
No, because it should be in our bag already. So I need the 100 milliliters over 45 minutes times my drop factor, 20 drops per milliliter. Okay, now the pen doesn't want to do this again. Okay. So 20 drops per milliliter. Now, do I have to do a time conversion? Since I'm already in minutes and I want to calculate drops per minute, do I need to convert my time?
No.
No. So my milliliters cancel, leaves me in drops per minute. So I'm going to multiply 100 times 20 and get 2,000. Divide it by 45, which some of y'all are probably already ahead of me. and I get 44.44 drops per minute. So that's going to go to where? How many drops per minute would I actually set?
44.
44. Because that even rounds to 44. Okay. So with the gravity flow, I'm still taking my amount in milliliters over my time times my drop factor. Which is drops per milliliter. And that gives me drops per minute. Now, sometimes I'll have to convert my time if I'm given in hours. Okay, y'all look at y'all do number 8. Okay, so did we get the same thing? $41 or 42 drops per minute?
How many? I got 31. What did you?
Okay. Oh, hang on a minute. Can y'all figure out what I did wrong?
Yeah, you put a 72 instead of 60 maybe?
Well, 15 goes into 6 4 times. I did 24 times 3. I don't know where that 3 came from. So it should be 24 times 4, which would be 48. So 3,000 divided by 48. Wait a minute. 24 times 4 is 96. Swear today. I was doing math just fine this morning. Okay, so that should be 96. So 3,000 divided by 96 is 31.25, which would be 31 drops per minute. I was reading the problems correctly and everything this morning. Not transposing numbers or anything. All right. Now, number 9. Notice it has the 3,000 milliliters at 125 milliliters per hour. So I've got a rate. But then it gives me a drop factor of 10 drops per milliliter. And it asks me to calculate the flow rate. So anytime you're given a drop factor, your flow rate is going to be in drops per minute. Okay, even if I don't ask for it in drops per minute, if I give you a drop factor, it's an automatic drops per minute. So y'all work this one out and see what you get. See if I can get the right answer. Okay, so did I get the right answer this time? Here's you another one for practice. Y'all work this one, number 10. All right, so did everybody get the 50 drops per minute? Okay. Questions yet?
No, ma'am.
Here's another one, number 11. You got D5, 1/2 normal saline, IV with 20 milliequivalents of KCl, which is potassium chloride, per liter. You run at 25 milliliters per hour. You have a drop factor of 60 drops per milliliter. Okay, so y'all tell me, is my answer right?
Yes.
Okay. All right. Let's work one more. Okay, so somebody tell me, what did you get for your flow rate?
20 drops per minute.
Okay, so 20 drops per minute. So did everybody get that? Or do I need to work it out? Y'all okay? All right. I can't hear anybody. All right. So we have a shortcut method that we can use if we're giving it in milliliters per hour. So if we're given the rate, just like we were up here, okay, in the 25 milliliters per hour, then I can use this shortcut method because it's milliliters per hour to milliliters. We're converting it to 60 minutes. But what I'm doing is I'm taking my 10 drops per milliliter. I remember how I did this a while ago. My milliliters per hour times my 10 drops per milliliter. And then I've got to convert my 1 hour to 60 minutes. And so what I'm going to end up with is when 10, I reduce, 10 goes into 10 one time, 10 goes into 60 6 times. So I'm left with 1/6 drops per minute. And that's when it's 1 milliliter of 1 hour. But notice how that I've got a 6 in the denominator. This is how you find your constant. So for the 10 drops per milliliter, my drop factor constant is 6 because 10 goes into 60 6 times. 15 drops is 4 because 15 will go into 64 times. So same thing with 20, I have a drop factor of 3, and with 60, I have a drop factor of 1. So the rule, or what we're going to use, is whatever our milliliters per hour is over our drop factor constant. Now, I'm not going to use the milliliters per hour. I'm just using the number. So I'm looking for the milliliters per hour, but I'm going to use just the number. And then I'm going to find my constant. So my constant for 10 drops per milliliter is 6. So I'm going to take 125 and divide it by 6. And I get 20.83, which would give me 21 or 22 drops per minute, depending on how we round them. So anytime you're given the rate of milliliters per hour, you can use this shortcut. So let's look at 14. I've got 1,000 milliliters at 150 milliliters per hour. So here's my rate. I have a drop factor of 15 drops per milliliter. So that makes my constant 4. So I'm going to take 150, divide it by 4. And I'm going to have 37.5. So I'll have 37 drops per minute, or 38 drops per minute. So whichever way you want to do that one. Now, I don't like the drop factor constant because I like having my units of measure where I can cancel them. But if this works for you, then use it. I'm okay with it. But you can only use it if it's like milliliters per 1 hour. Okay, so any questions?
Oh, ma'am.
Okay. We got 30 minutes still. Now, I'll probably have to come back and do some of this on Wednesday. But this is adjusting the flow rate. So if you've ever spent time been in the hospital, sometimes they put your IVs in your elbow or someplace where they can get kinked. And so the IV doesn't flow. And it can be through an infusion pump or through the gravity flow. Both of them, they work the same way. So if my husband's the world's worst at this because he always sits with his arms bent. The only vein they can find is a good vein is the one in his elbow. So his IV always gets kinked and they have to generally restart it at a different rate. And so this is what happens is that you're checking your patients and you find that, they're not used as enough. How do I want to say that? Their IV has not infused like it should have. Either it's gone too fast or it's gone too slow. You have to do this with gravity flow. You need to do it with the infusion pumps too. So this one says that we have an order for 1,000 milliliters. Where's my eraser? So 1,000 milliliters at 125 milliliters per hour for 8 hours. So we know what the rate is. We know that we have to have 100. Hang on, Rob. I'll have to call you back. I didn't mean to answer that one. I apologize. 1,000 milliliters that's going to infuse over 8 hours. We're using the gravity flow because it gave me a drop factor of 10 drops per milliliter. And it says the IV is correctly set at 21 drops per minute. This 21 drops per minute, my pen back over here, is my original flow rate. Okay. So that's what, when it was started, that's what the initial flow rate was. So you're coming through, it says during your regularly hourly IV monitoring at the 4th hour. So at the 4th hour, this means that 4 hours have passed. Or after 4 hours. You find that 600 milliliters is remaining. So we have 600 milliliters remaining. The hospital allows a 25% IV variation, IV flow variation, and that'll make sense in a minute. And this is standard for us. We'll use that 25% mark on all these problems. With careful patient assessments, and if the patient's condition is stable, and our patients will always be stable. Now, they use that 25% flow variation because when you reset that, if you reset it, if there's too much of a variation or between what the original is and what the new is, you can give the patients too much fluid. And it'll saturate their body tissue and they basically drown in their own tissue. So there's a process to this. So the first thing is we get the pen to work. Okay. So first is our original. We have to find it if we're not given it. Our original drops per minute or flow rate, whatever you want to call it there. And then second, we have to find the new flow rate. Okay. So to find the new flow rate, we're using our remaining fluid over our remaining time. And then, of course, times our drop factor. And then times our hour over 60 minutes if we need it. So for this one, our remaining fluid is 600 milliliters because that's what it has in the IV bag. So 600 milliliters. Now my remaining time, I have 8 hours is what it's supposed to flow. I'm after the 4th hour, so I have 4 hours remaining. So I'm going to divide this by 4 hours. And then we're still using the same IV tubing. So I have a drop factor of 10 drops per milliliter. And then I've got to convert, because it's in hours, I have to convert 1 hour, 60 minutes. Okay, so my milliliters cancel, my hours cancel, 10 goes into 60 6 times. So I have 600 over 4 times 6, which is 600 divided by 24. And I'm going to have a new flow rate of 25 drops per minute. Okay. And the third thing we have to do is find our percent of variation. Okay, so we're going to take our new flow rate minus our original divided by our original, then times 100, so it can be in a percent. So our new flow, our new flow rate is the 25 drops per minute. The original was 21, and so I'm going to divide it by 21 because that's the original. Multiply it by 100. So 25 minus 1 is 4, divided by 21. I get 0.19 times 100, and I get 19%. So the key is that this flow rate, the 19%, has to be less than the 25%. Well, let me write over there. And so this does. So then I'm going to adjust the flow rate to my new flow rate, which is 25 drops per minute. So did I just blow your minds? Pretty much.
When you said adjust the flow rate, I think I missed.
Okay, so this whole thing is about adjusting the flow rate. When we have,
Okay, I see.
you see it now?
That means it wasn't 25, so we bring it down to 19. That's what we're looking for.
Yeah, or we got to look for the 19. You know, there's 19% variation between the original flow rate and the new flow rate. What the new flow rate would be for the remaining fluid or for the 1,000 milliliters to infuse in 8 hours. Okay. Let's look at 16 for a minute. All right. I got 15,000 milliliters that has to infuse in 12 hours. Okay. We're not going to worry about anything else just yet. I check it. 6 hours. Got 850 milliliters remaining. 6 hours is my halfway point, right? Half of 1,500 is 750 milliliters. So this IV fluid should have infused, if it infused at the correct rate the whole time, it should have infused 750 milliliters. So I should have 750 milliliters remaining. But I don't. I have 850 milliliters remaining. So that tells me it is infused too slow. Something has happened to my original flow rate that it's not flowing at what it should be. So it's either the tubing's been kinked or somebody's messed with, shut it off or something. Somebody's messed with something. So we've got to determine, is the percent of variation, is it less than 25% between the old flow rate or the original flow rate and the If it is, then adjust it to my new flow rate so it can finish infusing within the 12 hours. Does that make sense to everybody now? Okay. So on this one, I kind of got it laid out better. I have to find my original flow rate. So I have 125 milliliters per hour and a 20 drop per milliliter drop factor. So since that one's in milliliters per hour, I can use my shortcut. So 125, and my shortcut or my constant for the 20 drops per milliliter, my constant is 3. So 125 divided by 3 gives me 41.6. So I'm going to say 42 drops per milliliter or per minute. I'm going to go ahead and round it up. And then I've got to look to find out what my adjusted flow rate is. I've got to know how much time do I have remaining. Well, I started at 12, or I had 12 hours total. I'm checking it after 6. So I have 6 hours remaining. And then it told me that I have 850 that are remaining. So to find my adjusted flow rate or my new flow rate, I'm doing 850 milliliters over 6 hours times my drop factor of 20 drops per milliliter. My time conversion, 1 hour, 60 minutes. So hours are going to cancel, milliliters are going to cancel. And then I know 20 goes into 21 times, 20 goes into 6 3 times. That leaves me with 850 over 6 times 3. 6 times 3 is 18, so 850 divided by 18. And that gives me 47.2, so I'm going to say 47 drops per minute. Okay, so if my percent of variation is less than 25%, then I can adjust my IV to 47 drops per minute. So for my percent of variation, it's the new, which is 47, minus the original, which was 42, divided by the original, which is 42, times 100. So 47 minus 42 is 5, divided by 42 times 100. And that's going to equal 0.12. I had to round that one, times 100, which gives me 12%. So since my 12% is less than my 25%, then I can adjust my flow rate. So what am I going to do is I'm going to adjust the flow rate to my new flow rate, which is 47 drops per minute. And this way that my 1,000 milliliters or 1,500 milliliters of solution will infuse over 12 hours. Okay. And I know I probably just blew your mind with these, right? Okay, here's what I'm going to do. You've got 17 and 18 to finish this section. The answers, I'll open them. I don't know if I'll open them today or not. May wait and open them Wednesday. But go ahead, and you can, as far if you want to, before everybody leaves, and you can kind of work as a spread out group and talk through it. But work 17 and 18, and still use your spacing and everything, your social distancing, and see if you can work through 17 or 18, or work it at home and using the video and the notes. Sometimes it works better if you work as a large group or a small group. But this is where I'm going to stop, and then I'll answer questions over 17 and 18 on Wednesday. Okay? All right. No questions? Questions?
No, ma'am.
Okay, so say y'all are frozen on my end again. All right, so I'm going to, and I hope I recorded this. Yeah. All right, I'm going to stop recording and get off of here. Y'all have a good week, and I will see you Wednesday.